Okay, welcome back to the series of this number system video lecture that we have discussed in the last lecture, and I have shown you that how actually a number can be represented into decimal to binary. Okay, so now let's take out another example. Let's see the other number system as well. So now let's take a number in decimal here. So what we're going to do, we're going to see the point here. We're going to convert a decimal number to octal number system, as well as we're going to see a decimal number can how can we convert into hexadecimal number system. Okay, so let's take out one example. Let's take a number 88 is in decimal. So what we want? We want its equivalent number into octal, as well as we want its equivalent number into hexadecimal. So let us see how we can do this. So earlier, if you remember, when we perform conversion a decimal number to binary, we have divided by 2 because base of the binary number system is 2. So here, to convert a number into octal, what we're going to do, we simply divide the number by 8 till the quotient part become 1. Okay, so let's do this here. 88 is the number. So if you divide it by 8, so here remainder is 0 and it will become 11. Similarly, if I further divide it by 8, remainder will be 3 and quotient part become 1. So see, very easy here, just division operation we need to follow, series of division operation. And now if I want to place the octal number here, what are you going to do? We simply just going to write from bottom to top. Okay, 1, 3, 0, and it should be in octal. So let me show you with the calculator that my calculation is correct or wrong. So here I am taking the programmer calculator present in the Windows operating system. So now here you can see what I'm going to do. I simply going to type the decimal number 88. So now you can see in the octal here you can see it is represented as 130. Decimal is 88. That means whatever the process I am following, it is absolutely correct. There is no issue. So now let's do the second one. How to convert a decimal number into hexadecimal. So let's take the same number, and instead of dividing it 8, we're going to divide it by 16. Okay. So if I divide it by 16, the quotient part will become here 5, and the remainder will be 8. So what is its equivalent number in hexadecimal? 58 is the hexadecimal number of 88 in decimal. Got it? Very easy. Let's take another number where we can use these alphabets as well. A, B, C, D, E, and F for hexadecimal. So let's take a number as a 45. Okay, what we want? We want this. 45 in decimal. We want its equivalent number in hexadecimal. Let's solve this. 45. Let's divide it by 16. What is the remainder? 13 is the remainder. Okay, so we all know that a hexadecimal number is represented the digit using 0 to 9, and A to F is the alphabets. Here A means 10, B means 11, C means 12, and D represents 13. So this 13 is actually what? Is D. So how you going to write this in hexadecimal? 2D. Just put 16 over here. So now anyone can understand it is a number in hexadecimal format by seeing the base. Okay, so these are very straightforward approach how we can convert a decimal number to binary. We did it in the last video. And how to convert a decimal to octal, and decimal to hexadecimal number system. Okay, so in the next video we're going to see how can we do the opposite thing, the reverse thing, binary to decimal, then octal to decimal, and hexadecimal to decimal, opposite one. Okay, so let's have stop here. Okay, so thank you very much. Please like our videos and kindly subscribe my channel as well. And you will get this such kind of tutorial lectures in almost every day. Thank you very much.